Okay, in this video I want to go a little bit further with this logistics growth example with this lizard population. So we looked at part A and part B already in previous videos. So in this video I want to know what happens if everything is the same except the growth rate of these lizards jumps up from 150% to 249%. So notice everything else is going to be the same. So I'm going to just copy this recursive sequence. Initial condition is the same, carrying capacity is the same. The only thing that changes is this R. The growth rate instead of 1.5 is now going to be, up in the wrong spot, is now going to be 2.49. So what I want to do is go back to my Google Sheets and then input this new recursive sequence and see what happens. Okay, so I don't actually need to change much. Right? I've got the recursive sequence and the scatter plot we generated in the last video. Really all I need to do is change my recursive relationship. Instead of 1.5, that's now going to be 2.49. And that doesn't change anything. That's just something for us to look at. So if we go to this lizard population, column B, initial population is the same. If I go down one, everything in this equation remains the same except that growth rate. Instead of 1.5, I'm going to delete that and write 2.49. Click on Enter. And notice there's some change right here that changed from 930 to almost 1200. But if I look in the next cell down, it's back to that 1.5%. I don't want that. The growth rate should be fixed at 2.49. So I'm going to go back to the cell above until you see the solid square in the bottom right. Hover over that, click, and drag down to 20. And notice the scatter plot changes also. And so I have a new scatter plot showing how this lizard population changes over time. So recall in the last example, the population seemed to hit that carrying capacity of about 1,000 and stop. With this growth rate, what's happening is the lizards are growing past the growth rate, running out of food or shelter or whatnot, and then they're bouncing back in this kind of a periodic behavior. So if we want to know just what happens, I'll write the lizard from around 600 to 1200 each year. Okay, so that's looking at part C. What happens if the growth rate is 249%? I think it's going to be a little more interesting. What happens if this population is even more? These lizards grow at a higher rate, 290%. So I'm going to go back to Google Sheets. And instead of 249, I want to change this to 290%. So R becomes a 2.9. Click on Enter. Again, keep in mind that only changes that first cell. So I need to highlight that first cell right here after the initial condition. Hover over the bottom right corner. Click, drag down. And mathematically we call this kind of a chaotic form. It's not really periodic. The populations keep jumping up back and forth between 600 1300 is way too big, then drops down. So we get this kind of a chaotic pattern. So we have the graphic right here. I'm just going to write chaos. And if you want, go back to C2, play around with this rate. What if we change that to over 3%, over 4%? What happens to this population pattern as it changes?